Okay, we're back here with this cubic equation, and we've actually figured out quite a bit of stuff. We know that that's 0 and 12. We know that that's 4 and 0. And we know that that point there is minus 3 and 0. And that's minus 1 and 0. So we know the x-intercepts and the y-intercepts. The next question, they say determine the point of inflection. The point of inflection, given that g of x is equal to minus f of x. G of x is minus f of x. Determine the point of inflection of g. Well, they say there's a new function. There's a new function, g of x. Well, that's this here. We're just supposed to make it negative. So this just turns into x cubed minus 13x. We just multiply it all by negative 1. We get this new function, which they say is the minus, the negative of the other one. So all they want us to do, point of inflection, okay, but they want us to multiply f by negative 1. Well, let's just see what we would do. We'd multiply it by negative 1. This would turn into x cubed minus 13x minus 12. And then we would find the derivative. Well, the derivative of f is, if we did it, is negative 3x squared plus 13. But the double derivative for finding the point of inflection, we take the derivative one more time, is minus 6x. Well, that's minus 6x equals 0. So x equals 0 is the x value of the point of inflection. The point of inflection must happen at 0 and 12. Well, we could have redone this, and we'd actually get, if we had done g of x and done the derivative and then done it, we'd get the point of inflection is 0 and minus 12. But the point of inflection of f is 0 and 12. So the negative of it, the point of inflection, would be 0 and minus 12. Okay, that's how that works. Let's look at the next question. So points of inflection is we take the second derivative and we let it equal 0. And that's the place where they change its concavity from concave in this question, concave up, to concave down. And look, you can see it happens at 12. But if you made it negative, would it be down here? It would just change it to minus 12. Okay, let's look at the next question. Calculate the values of x for which the tangent to f is parallel. So we want to find out where the tangent is parallel to this line. We don't really care about where the line's going through. This is a fancy way of saying find the tangent when the gradient's minus 14. Find the tangent because it's parallel to this line. They mean find where the gradient on f is going to be minus 14. That's what they say. That's all they're saying. So all we do is we go to f, we take the derivative, we get minus 3x squared plus 13. Now we care about when this derivative equals minus 14. Okay, so we make the derivative equal minus 14. Let's find out the x value where that happens. Well, we take away 13, we get minus 27. We divide by negative 3, we get x squared equals 9. Well, there are two places where that gradient's going to be minus 14. That's if x is 3 or x is minus 3. If we went back here and looked and say, well, what are they talking about here? Well, when it's 3, if you stop right here at 3, they're saying that thing there, that gradient, would be minus 14. And over here at that other value, there's minus whatever it is. Oh, at minus 3, I guess it's negative 14. That's the gradient at those places. Okay, so that's your answer for when the gradient's going to be parallel, when the gradient's going to equal minus 14. That's meaning those tangent lines that are right on that curve will have a gradient of minus 14. Okay, I hope that helps.